Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. Flexible printed circuits, the future of wearable electronics. In 1998, when the world was excited about the first mobile phones with color screens, scientists from European universities were working on something else. Their goal was not to make a smaller phone, but to create circuits that could bend, roll, or be attached to fabric. Today, after over 20 years of research, flexible electronics are no longer just science experiments. They are becoming a key part of wearable, medical, and interactive products. What are flexible printed circuits? FPC. FPCs are thin, light electronic structures made on flexible materials like polyester, PET, polyimide, PI, TPU, or PC film. Instead of milling or etching like in classic PCBs, conductive paths are printed using screen, inkjet, or flexographic printing. Conductive materials include silver inks, graphite, carbon, and conductive polymers. Benefits: flexible and fits the body or clothes, reduces size and weight of the system, can be built into packages, clothes, or PET film, easier to assemble, fewer parts needed, lower cost for small series and prototyping, better shock and vibration resistance in mobile use, applications in wearables, monitoring health, ECG, EMG, temperature, skin moisture, sports clothing with training sensors, smart bracelets, necklaces, rings, e.g. pulse rings, single-use medical devices, textiles that react to touch or movement, clothes with NFC and RFID for ID and tracking. Difference from traditional PCBs. Classic PCBs are stiff and made for fixed housings. They're not good for wearing or sewing into clothes. FPCs can bend, be sewn, or glued into fabric. This gives a big advantage in comfort, design, and looks. But it also needs different design methods, strong flexible materials, and good planning for bending stress. Rising demand. In rich countries, people wear 3 to 7 electronic devices daily: phones, watches, glasses, sports bands, headphones, smart clothes, shoe insoles, diagnostic patches, and sleep rings are more common. By 2030, the wearable tech market may reach $160 billion. Technical info and parts: Henkel Loctite, R, EDAC PF 410, silver paste, conductivity greater than 10 to the power 5 Siemens per centimeter. Elantas Bectron, or CP6662, silver paste, resistance less than 0.010 ohms per square per mil. Heraeus Prexonics, R, nanometallic ink, 150 nanometers to 5 micrometers, 20 to 50% silver conductivity. Tactirian Plion Flex, sensor, flexible sensor, bending radius less than 10 millimeters, fast response less than 5 milliseconds. Design challenges: joining with fabric without changing comfort, resistant to bending, washing, water, and chemicals. Accurate sensors for touch, temperature, and pressure. Must work with BLE, NFC, LORA. Materials must handle UV and minus 20 degrees Celsius to plus 85 degrees Celsius. FunTech, FAX, roll-to-roll printing goes up to 50 meters per minute on 50 to 100 micrometers. PET, printer sent in Ulu, tests flexible parts in real environments. Henkel has 40 plus types of inks and pastes for printed electronics. Case study: for Polyend, a musical instrument maker, LC Electronic created pressure-sensitive mats using Henkel's Loctite ECI 700 4HR carbon ink. It sticks well to PET and has stable resistance. Specs: 21.4% solids. Density 1.09 grams per cubic centimeter. Viscosity 10,250 millipascals per second. Surface resistance 3,500 ohms per square per mil. The sensors were printed and added to soft silicone mats. The final product was flexible and had reliable signals, perfect for musical controllers. Looking ahead, FPCs will be a key part of new wearable devices. Materials are getting thinner and better. Companies like Tactarian make sensors that bend a lot and still work. Automotive, medical, and fitness sectors show more interest every year. Summary: back in 1998, few believed bendable circuits would end up in shirts, bandages, and rings. But today, when we need more ergonomic and smart tech, flexible electronics are no longer just the future, they are already here. CTA: want to know if your device can use printed technology? Ask our team. Download our mini guide on inks and substrates. See examples of FPC in textiles and medtech at www.lcelectronik.com. Watch silver ink printing in a roll-to-roll line. Sign up for PrintoSense workshop. Designing with flexible hybrid electronics. Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. This episode of LC Insider was powered by LC Electronic, where printed electronics meet precision engineering. Visit lcelectronic.com to explore materials, cases, and technologies we talked about today.